Good morning, everyone. Today, I like to do a introduction on the research into reliability. I'm the center director and currently working in Chang University in Taiwan. Well, where is our university? Well, the university, if you look at the Taiwan map, and you can see the airport. Let me get a pointer. You can see the airport. Now, between airport and Taipei, we are right in the center. So in other words, anyone who want to go to Taipei, definitely will pass through our university. It's in the middle. And Chang University ranked 510 in the world university ranking and ranked number 7 among all the Taiwan university. And so let me introduce this our university. This is our beautiful campus. Okay, this is my center.
Professor, we cannot hear the audio of this video. Can you please introduce your department along with the video?
Along with the video?
Yes, can you? Yes.
Can you guys cannot hear?
No, we cannot hear the audio of the video.
Oh, I see. Anyway, basically, this is my center photo, and I introduced a few joint program with the Singapore National University of Singapore, as well as the Singapore University of Technology and Design. We can have a joint degree, meaning that the student can study here for 9 months and 9 months in Singapore. So we can get a dual degree. This is a very attractive program, and there are quite a number of Indian students join this program. They get 2 certificates. One is from Chang University, another one is from Singapore University of Technology and Design. SUTD, Singapore University of Technology and Design, is a new university, well, not really new now. It's a university that established by Singapore government with the US MIT. So it is a very prestigious university and the teaching is very good. I just want to make a correction. My students told me that Chang University now ranked 500 in the world ranking. Okay, so this is about our center. And as I said, that our center is the only reliability science research center in Asia, the only center. And it's also the only center is invited. It is a business partner with the world #1 automotive power semiconductor company in Germany, that's Infineon. Now about me, I'm a committee member of IEEE Reliability Standard Working Group for 2, now it's 3, recently added another one. The 2 of them is IEEE 1624, which is a standard for organization reliability capability. Another one is 1431, which is a guide for selecting and using the tool for reliability predictions. I'm also a committee in the IEEE Electron Device Reliability Physics to oversee the electron device reliability. And I'm editor of a few journals such as the IEEE TDMR, stand for Transaction of Device and Material Reliability, scientific report, which is a Nature publication, and then also microelectronic reliability, NDPI in price size, Frontier is thin solid film, and so on. So I have been the editor for several journals. Now, this center have many projects with the industry, as reliability is a very practical thing and it's also very theoretical. So basically, reliability is really a joining of a science into a real practical world to help the company. Now, I work with NASA. Just now, Lynn has mentioned about NASA. And NASA actually, we work together to look at how the device when it go up to the space, there'll be proton and neutron radiation. So how's the device survive? So I also work on with TSMC, Taiwan Semiconductor Manufacturing Corporation. We're again looking at the proton radiation on the silicon devices, because these are the important things. You might want to ask me later on why these are becoming important. Then I work on the light-on power, work with light-on power, which is a power semiconductor company, where I help them to do a root cause analysis of failure for the high-power devices and also the molding devices. Then I also work with the Land Transport Authority in Singapore to look at the lifetime of their bus fairing system. SGS Taiwan, I'm a consultant for reliability computation. Infineon in China, and looking at the detection of material using radar. MA Tech is one of the biggest failure analysis company in Taiwan, and I have them in conducting the reliability test and analysis. MBI is a company that producing a lot of LED. Today we're using a lot of LED, high power LED. They are the one who producing the driver for the LED. So I have them to do a simulation and measurement analysis, and so also reliability testing. G-Tech is a company that producing industrial computer, which I give them reliability training. Star is a high power LED company, and so I help them to identify the failure mechanism in their module. Catman is a company that there is actually.
Sir, you are on mute. Sir?
Yep.
Yes. Yes.
Okay now?
Sorry. Yes. Yes.
All right. So Catman is a company producing simulation software, and I give them consultation on those things. Then there's another company already in Chinese, I don't know English name, but they are working on the gallium nitride chip reliability. Moxa is a company that producing Ethernet for the transport for train and many things else, and their Ethernet system for the world, and I have them to implement the design for reliability. Secteria is a German company in Malaysia, where I also help them to do the reliability testing for their microelectronic devices. So you can see that there are actually many, this center, since it started in 2015, has been working with many industry and supporting them, applying the science into real industry. The scope of the reliability research in this center is all around, from material reliability into device reliability, into circuit reliability, as well as system reliability, and also to help the existing product to improve reliability. So what exactly reliability and why they are important? I think Ling has mentioned just now, but let me give you an introduction. Okay, today customer make their purchasing decision based on which product can offer them the best value. But then the question is, what is called best value? What's value? Well, product value really is equal to the customer perceived value divided by price. And what is customer perceived value? Well, it relating to the, for when you buy something, how do you think that this product is good or bad? How do you value them? Well, it depends on your performance, on the performance of the product, as well as the reliability, as you will see later on. So in other words, achieving high product reliability at reasonable cost is a key success factor in today's electronic industry. The cost comes in because price is a denominator in the formula. You see, in general, supplier are producing product with some attribute. On the other end is a customer that want to purchase a product with some goal and need in mind. Now, only when this goal and need are aligned, then this alignment will creating the value. So therefore, today's the product or service process value only to the way that how the alignment is made, the degree of alignment. Well, let's look at the example here. So Toyota, Toyota car, I think everyone know that. But in 2010, Toyota car recalled more than 14 million vehicles worldwide. Why? Because of the braking issue. And these brakes are supposed to be smart. And so when they press the brake, it's supposed to stop. But what happened is that there's a problem in the braking system, so that when you brake, in fact, it becomes accelerating. And this is the so-called the computer controls of vehicle. The computer send the signal wrongly. Why it send the signal wrongly? Because the sensor are not producing the right signal. And this is reliability. So Toyota faced 138 potential class action lawsuit and nearly 100 people injured or even died. So at the end, the Toyota need to pay a penalty to the US 16 million to the US government and also cover all the costs. So what we can see is that, in fact, reliability can cost life. Reliability, as just now we share in the NASA space shuttle, can cost life. Reliability can cause company to lose a lot of money. Every company now understands the importance of reliability. In fact, if you were to look at the things here today, why it is important in our life, 2010 people did a survey done by the American Society for Quality. These are the 6 attributes that the customer, including ourselves, think that is important. If you were to look at these 6 things, first of all, you can see that from 3 to 6 is all relating to service, because people try to order things online. The order accuracy, on-time delivery, building accuracy, all these are online. But in order to achieve this thing, you need a computer system reliability. Now, product availability, meaning that when you want to use a product, it is available for you to use. This relates to product reliability. Deliver condition, that is when you buy a piece of glass, it is really a whole piece, not a broken piece. This packaging, package reliability, how the package is good enough. So therefore, you can see that in today's consumer, including ourselves, we want to hope that we assume, but it is really is hard work to ensure that the computer system and the ordering is reliable. The product you get is reliable. The package that you deliver the product to you is reliable. So therefore, in short, the key strategy for global competition is price, because the denominator, service, because this is relating to the order accuracy and all those things, reliability, which cover all, and of course, time to market. Now, even the first 3 is already good enough for you to secure your market. And if you have a good price, but if not reliable, your people will no longer buy your product anymore. You have a good service, but product is not reliable, is also the end. Even you have a very good product, new product, time to market is very short, but it's not reliable, it is also going nowhere. So in the sense, reliability is a core of a global competition, is a core of a survival of a company. And today's situation is even worse, because what customer want is to reduce the cost, while the reliability is to improve and performance has to be improved. Well, it is very challenging, because the basic axiom for the system reliability is that the more complex the system, the more lower the reliability it is, unless something is being done. This can be easily seen by a diagram here. This is what we call a series connector system, where a system contains 3 subsystems. And they are series connector, meaning that the system can work if and only if all the 3 subsystems are working. Therefore, the reliability of this entire system is equal to the probability that this subsystem R1 is working, R2 is working, R3 is working. And these are all probability. If their number is all less than 1. So therefore, you can see that just by looking at, if you have a 3 subsystem or 3 components, even though each of them have high reliability, but your system reliability is poor. If you were to make it to be more complex, because today we are talking about smart devices, it will go bound to be more complex. If you have 15 devices, even with the same reliability, your system reliability down to below 50%. It is totally unacceptable. So therefore, to improve it, you have to improve the reliability for the subsystem to be 0.99. Then you can up the system. 0.99 from 0.095 look like it's only a small number of 0.04. But in total reliability, if you learn later on, this implies that for 0.95 is 10 years, for 0.99 is 400 years. It is a big jump. So therefore, it is not trivial to improve the reliability just by brute force method. And therefore, looking at that, if you would want to improve the performance, you definitely have to increase the complexity of the system. But as you can see just now, increase the complexity will reduce the reliability. Now, of course, you can use a higher reliable component or using redundancy to improve your reliability, but this will increase your cost. But as I say, customer want to reduce the cost, but improve their performance, improve the reliability. This is really a dilemma. So is there a solution? The good news is that there is a solution, and this solution comes from this center. Because the current reliability engineering is that the reliability of the product is obtained through testing of the product that already make. And then if fail, you need to do failure time and then failure analysis on the product so as to improve. So all these are after the facts. So as I said, that the product has to be designed and made before you know it. If it fail, you need to redesign, you need to reprocess, and all this will increase the cost and the time to market. This does not meet the current trend. So therefore, we have to find another way to do that. We have to find a way whereby we can predict the product reliability while it is designed before it is made. And then we have to do it when manufacturer do it right the first time. And this requires multidisciplinary. You need to require the knowledge of the reliability physics, which means that what are the possible failure mechanisms? What are the acceleration model? Because usually the test is done at a higher stress condition. We also need to have a reliability testing theory to look at how to perform the test, how to design the test, how to select the sample. After the test, you got the data, you need to do statistical analysis. And this statistic is totally different from the normal statistics the school is teaching, because this statistic including time. So it is a reliability statistics. So altogether, if you want to ensure the reliability of a product, you need three disciplines altogether, working together. One is the reliability physics, reliability testing, reliability statistics. And this requires students from many different disciplines. We need a student from physics with the basic of quantum mechanics, radiation, device physics. We need people from chemistry because the failure sometimes relating to chemistry and material science. We need statistics because we need to do a lot of statistical analysis. We need industrial engineering to look at how to do the testing. We need electrical, mechanical, and computer engineering because computer reliability is one of them. Electrical, mechanical is for the design of the product itself. So we need all kinds of discipline. This is one of the very few subjects whereby such multidisciplinary is required. And if you look at the job survey in 2019 by this American Society for Quality, you will see that among all the engineers here, the two highest paid job that is compatible with manager or even with the director of a company is software quality engineer and reliability engineer. You probably know why, because these two are what company need. Software quality, because today we rely so much on the software, IoT, and all those things. Reliability engineer, because company, it is a core of a company's survival. Company are looking for people because that's why they're willing to pay them high if you have the skill. So among all the engineering, these are the two. All right, so with that, I hope that you can roughly get some idea about reliability. And I want to quickly tell you that in this center is very unique among all the university because we have a state-of-art research facility. I can go quickly. We have an environmental test facility for temperature-related outdoor, and we have a battery tester. We have electrical characterization. We have a material analysis tool. We have a microscopic examinations and all those. So we have many tools. All these tools are not cheap. They are easily a few millions NT dollar. And it is very hard for a university or even for any center. In fact, our equipment is even better than a lot of companies, in fact. And so students coming here, you are able to really hands-on on this expensive equipment that you will probably never able to have a chance on it. And I'd like to share that for this 30 over years of teaching, I've trained many students, and these are my students that have graduated. Okay, and they're all together 26, And many of them, as you can see, my very first student, Dr. Gao, is the Director of Engineering in Qualcomm. And then I got many students also that they are either in SMIC, Google, and Hewlett Packard, Intel. Udi will share more about that. And I got actually 4 students in Intel, okay? And Udi is the most recent additions. And then we have a Global Foundry and so on. So the reason that this my student easily find a job, and especially the big company, because this company understand the importance of reliability and they look for these people. All right, this is my team. As you can see, if you come over here, you don't feel foreign. There are so many Indian students with me, and you're welcome to join. With a PhD, 4 years. If you master, PhD can be 5 years, because you can 1 year, supposed to be 2 years master, but 1 year you can work in the industry project and then continue on for your PhD. With that, I thank you for this opportunity.